Okay guys, your first question on every one of these, is it a triangle?
No.
Is this a triangle?
No.
No. Now some people are going to tell me this is a right triangle. That's not true. This is not even a triangle. It's a line segment. This is 4.5. Here's 1.5 and here's 3. That makes a line segment, not a triangle. Not a triangle. You can't do that problem. You can't do anything with it. You can't identify a triangle when it isn't. It is a line segment. Number 4, we're looking at 5, 5, 9. First of all, is it a triangle?
Yes.
How do you know?
Because
It's
5 plus 5
The two smaller sides give you 10 for a sum, and the larger side?
9.
9. The two smaller sides have to have a sum that's larger than the third side, the larger side. 5 plus 5 is greater than 9. It is a triangle. Now compare a squared plus b squared with c squared. You substitute it in. 5 squared? Is that 10?
No, 25.
25. We're going to compare these. 25 plus 25, and we're going to compare it to 81. Now again, do not say smaller or larger until you circle C. You're always checking side C. We want to know, is C too large, too small, or just right? C, we're always asking about C. This is C squared. It's too big or too small?
Too big.
Too big. That always makes it obtuse. By looking at the sides, we can tell immediately, 5, 5, and 9, that it is isosceles, of course, because two sides are equal. Isosceles, obtuse. Number 5. 5, let's see, 2, 3.75, 4.25. What's a triangle? Yes, no, who knows? What is it? Of course, 2 and 3.75. If you add these together, you take the sum of the two smaller. If it's larger than the third side, it's a triangle. It is a triangle. What kind of triangle is it? We have to take a squared plus b squared. It is a scalene, that's right. We can tell by looking at the sides. In fact, it's scalene. Now compare these. Make sure you use your calculator to double check. This is 2 squared plus 3.75 squared. We're going to compare that to 4.25 squared. That's 4. Well, that one I can't do it in my head. What is it? What's this one? 3.75 squared? What is it? 14? Point? 0.06, like that? Okay. And this one? Over here? 0.06. And these? So what is it?
Right.
It's a right triangle. If they're equal. I recommend that every time you do this exercise that you do this visualization. When you understand this one and can explain it to somebody else, you won't forget. What's happening is you guys learned something and 3 or 4 days later you don't have a clue what you're supposed to be doing. The only thing you need to do to remember things is teach it to somebody else. Show them that if you have a right triangle, then a squared plus b squared is equal to c squared. Or do this visualization with them. Now make C bigger. And you can see that it's obtuse. If C is smaller,
Acute.
it's acute. If C is just right, it's a right triangle. A squared plus B squared equals C squared. You need to be able to visualize this to use this theorem. You can't be looking it up in your notes all the time. That doesn't do you any good. I want it to be in the brain. What about number 6? Is it a triangle? 6 is? Okay, let's see. 1, 6, 6. That's a triangle? Yeah, 1 and 6 is bigger than 6, of course. 1 and 6, the sum is 7, and that's bigger than 6. Now remember, that has nothing to do with the angles. This is the sides, and it just tells us it is a triangle. A squared plus B squared and C squared are very easy to compare in this case, because you can do them in your head. 1 squared plus 6 squared, and we're going to compare that with 6 squared. That's 1 plus 36. We're going to compare it with 36. And of course, do not read this. 37 is greater than 36. No. The way you read it, you always ask about the hypotenuse, or C in this case. C is too small, which makes it
Acute.
acute. What else?
Es isosceles.
Isosceles. How about number 7? No what?
No es un triángulo.
It's not a triangle. It doesn't reach. If you have 6 and 2 and 4, oops, 4, a little bit. There's 2, there's 4, there's, oh, 7. There's 7. But you see the problem? They don't make it. There's no triangle here. 2 plus 4 is not bigger than 6. It's, sorry, 7. I keep writing the wrong thing. That was supposed to be 2, 4, 7, sorry. And 2 and 4 is certainly not bigger than 7, so it's out. Not a triangle. That's going to be E on your test, by the way. E will be not a triangle. Whenever it's not a triangle, it'll be E. Number 8, 3.5, 3.5, and 3.5.
No, mister, mañana va a ser el examen.
Well, day after, when we come back to class.
Va a ser, no vamos a hacer esto,
You guys will be on Wednesday.
esto,
Yeah,
sí lo vamos a hacer.
it's going to be the same test, just going to be different numbers, of course. Okay, is this a triangle?
Yes.
Definitely, 3.5 and 3.5. By the way, we can tell immediately and instantly that it is what kind of triangle?
Equilateral.
Equilateral. We also know that any equilateral triangle, you should be able to realize that this is true. This is just a fact. Anytime you have equal sides, you also have equal angles. What are the 3 angles? 60, 60, and 60. This is always true. It never changes. Equilateral also means it's also equiangular. On top of that, you also know immediately that it is acute, right, or obtuse? Acute, of course. It also happens to be isosceles. I know equilateral is a better answer, but it is also isosceles because it does have 2 sides equal, doesn't it? So it's all of these things are true, and you don't actually have to put it in the functions. You don't even have to put it in any kind of formula or anything. You just have to recognize. 9, 12, 15 is your next triangle. Is it a triangle? Yeah, 21 is bigger than 15. You check the 2 smaller sides against the larger side, and yes, it is a triangle. Test what kind? A squared plus B squared, and compare it with C squared. 9 squared plus 12 squared, and compare that with 15 squared. 9 squared,
81.
12 squared,
144.
44, and 15 squared is 225. And we're going to compare those. What do you get?
200.
225 and 225. When they're equal, they're just right, aren't they?
Yes.
Just the right size. This is a right. What else do you know about it?
Scalene.
Scalene. Right, scalene, because they're all different.